our world is constantly changing.
We inspire, we innovate, and we create.
Hi, I'm Cristian Orozco, and I'm here to teach you about science.
Let's start off with Newton's first law, or an object in motion will stay in motion and an object at rest will stay at rest, unless it's acted upon by an unbalanced force, that is. The plane set in motion stayed in motion, eventually being stopped by various factors, namely air resistance and gravity. We can still, however, clearly see that the object did stay on a relative path. The other plane was set at rest and stayed at rest. Because there wasn't another unbalanced force acting on it, it did not set back into motion.
Hello, darkness, my old friend.
But here is an object at rest. As you can see, this object tends to stay at rest. If we apply an unbalanced force, it will eventually move. An unbalanced force must be able to counteract opposing forces, namely frictional forces. It really just depends on how much force you apply. Newton's second law, force is equivalent to mass times acceleration. Here we can see a pedestrian twiddling his thumbs. Let's spice up his day.
Hello, darkness, my old friend.
If force is equivalent to mass times acceleration, we need to determine the ball's mass and how fast it was traveling. Now we can't really calculate that, so let's just say 15 meters per second. Multiply by 9 kilograms and you get 135 newtons, or 140 with significant figures. Here's another example. Calculate the force of the bottle after being kicked. First, mass the ball, then the force of Cristian's kick. Now, the force of his kick is actually mitigated and transformed into gravitational force. This change happens once the bottle hits its apex in the air. That same amount of force, disregarding resistances, is applied on the ground below after it lands. This leads into Newton's third law. Finally, Newton's third law. For every action, there's an equal and opposite reaction. It's pretty clear that the action of throwing the ball created an opposing action of, well, a clearly different magnitude.
Hello, darkness.
That's a result of frictional forces discussed earlier. It's also a result of Newton's second law. The ball has lower mass compared to the person, so naturally it has less force. Ideally, without any frictional forces, force would transfer infinitely without loss of energy. So don't worry, it hurts less than it looks, scientifically. Let's look at another example of energy transfer. How about a daily activity? Jumping. That is, if you aren't a total weeaboo or camp in your house playing League of Legends. Jumping is attained by the ground pushing upward on you, equivalent to the force you apply downward. As a matter of fact, if everyone in the United States jumped in one location, the Earth would respond with the same amount of force to the jumping power of everyone residing in the United States. But let's try not to shift the Earth's orbit too much.
Thank you for allowing me to teach you something new today. Goodbye, and God bless. I hope to see you next week.
Next time on Learning with Cristian.
Drop it.